Welcome to this lesson on solving one-step inequalities. Please make sure you have these notes in front of you so we can begin our lesson. The learning objective for this lesson says I can solve and graph one-step inequalities. So let's take some time and review some of our past operations and the inverse operations. Remember, the word inverse means opposite. So the inverse operation of addition would be subtraction. And the inverse operation of subtraction would be addition. The inverse operation of multiplication would be division. And the inverse operation of division would be multiplication. So for our inequalities, if we have the less than sign, you are going to have an open circle and your answers are going to be shaded to the left of that open circle. You're also going to have a greater than sign. You're going to have an open circle for the greater than sign, and all your answers will be shaded to the right of that open circle. And then we also have the less than or equal to sign, which you're going to have is a solid circle. It's going to be fully shaded in. And all of your answers will be shaded to the left of that solid circle. And then we also have the greater than or equal to symbol. You're going to have a solid circle, and your answers will be in the same direction of the right of that solid circle. So we can use inequalities in a real-life situation like baseball. The graph shows the number of home runs that the top hitters on a baseball team hit last season. So problem 1 says write an inequality that compares the number of home runs Nate hit to the number of home runs Josh hit. So if we take a look at Nate's right here, he hit about 15. And Josh hit in between 10 and 15, so that's about 12. So my statement says 15 is greater than 12. That is a true statement. That is a true inequality, because 15 is greater than 12. You could also write the same inequality as 12 is less than 15. They mean the same thing. For the second problem, it says write an inequality that compares the number of home runs James hit to the number of home runs Mark hit. So if we take a look at James hit about 19, and Mark hit about 23. So our inequality says 19 is less than 23. That's a true statement. You can also write 23 is greater than 19. It's still a true statement. So let's use these key concepts to discuss the following examples. For example 1, it says solve x plus 7 is greater than or equal to 10 and graph the solution on a number line. So the first thing I want to do is let's go ahead and draw a fulcrum down the center of the inequality. And let's start on the left-hand side because that's where our variable is. Let's go after the constant, so let's do the opposite of positive 7, which is minus 7. So let's subtract 7 on both sides. I can get rid of 7 minus 7, that goes away. Drop down the value of x, which is all alone. We've isolated our variable. And let's drop down the greater than or equal to sign. And 10 minus 7 would equal to 3. Notice that my variable does come first, so I know that my inequality is written correctly. So the value of x could be anything greater than or equal to 3. So let's go ahead and graph this on a number line. Here's 0. Positive 3 will be about right here. It's going to be a solid circle because it has a little equal to symbol on my inequality. And I'm going to shade everything to the right, which means anything to the right of this number line of 3 will make it true. So let's test it out. Pick any number to the right, like 10. 10 is greater than or equal to 3. That's a true statement. Let's go ahead and pick 3. 3 is greater than or equal to 3. That's a true statement as well. That's the reason why we have a solid circle. Let's pick a number to the left of 3, like 0. 0 is greater than or equal to 3. That is a false statement. So anything to the right of 3 and including 3 is a solution. Example 2 says solve x minus 3 is less than 9 and graph the solution on a number line. So the first thing I did was I rewrote the problem. And I'm going to draw a fulcrum down the center of the inequality. I'm going to start on the side that has the variable, so on the left-hand side, I'm going to try to isolate the variable. In order to isolate the variable, I need to get rid of the negative 3. So the inverse operation of minus 3 is to add 3 on both sides. This is an example of using the addition property of equality, because we had to add 3 to both sides to keep our scale balanced. Now that we've done that, we can cross out negative 3 minus 3, which becomes 0, and our x has been isolated. Drop down the less than sign, and 9 plus 3 is equal to 12. So let's graph all of our solutions. As you can tell, our variable comes first, so we know that this inequality is written correctly. So on the number line, I'm going to place 0 on the number line, and 12 would be to the right of 0. I'm going to use an open circle because the sign says less than, and it doesn't have a line under it. It's not equal to, so it's going to be open, which means 12 is not part of the solution. If I plug 12 into the inequality, 12 is less than 12, that is a false statement. I'm going to shade everything to the left on the number line, because anything to the left of 12 makes this true. So let's pick any number like 0. 0 is to the left of 12. 0 is less than 12. That is a true statement. So anything to the left of 12 on a number line will make this inequality true. So pause the video, complete the got it problems, and we'll discuss the answer in class tomorrow. Notice I have two got it problems on this slide, got it problem A and got it problem B. For example 3, it's to solve 5 times x is less than or equal to 45, and then graph the solution on a number line. So after rewriting the problem, let's go ahead and draw our fulcrum down the center of the equal sign. And we're going to start on the left-hand side of this inequality because that's where my variable is. So this is saying 5 times x on the left-hand side. That's saying 5 times x. Let's use the inverse operation of multiplication, which is division, and let's divide both sides by 5. This is an example of using the division property of equality because we had to divide 5 on both sides in order to keep our inequality balanced. So now that we've done that, 5 divided by 5 crosses out, and our variable of x is left by itself. Let's drop down the less than or equal to symbol, and 45 divided by 5 is equal to 9. So let's go ahead and graph this inequality. Notice the variable comes first, which means this inequality is written correctly. I'm going to place 0 on the number line, and positive 9 will be on the right-hand side of 0. Let's go ahead and use a solid circle because there's a line underneath the inequality that says equal to, and I'm going to shade every direction to the left. So let's try some numbers. Let's try using 9. 9 is less than or equal to 9. That is a true statement. That's the reason why we have a solid circle. Let's try any number to the left of it. Let's try 8. 8 is less than or equal to 9. That is also a true statement. That's the reason why it's in the shaded region. So anything to the left of 9, including 9, will make this inequality true. Anything to the right of 9 will not make it true. For example 4, it says solve x divided by 8 is greater than 3, then graph the solution on a number line. So after rewriting the problem, let's go ahead and draw our fulcrum down the center of the inequality. And we're going to start on the left-hand side because that's where the variable. Notice that line means division, so let's go ahead and do the opposite of division. The inverse of division is to multiply. So let's multiply by 8 over 1. But if I multiply one side by 8 over 1, I have to make sure I multiply the other side by 8 over 1. This is an example of using the multiplication property of equality because we multiplied 8 on both sides to keep the problem balanced. So now we can cross out the 8 divided by 8 goes away, and x is all by itself. Drop down the greater than symbol, and on the right hand side 3 times 8 becomes 24. So let's go ahead and graph this on a number line. Here's 0, here's positive 24. We're going to have an open circle on positive 24 because there is no line underneath the inequality. And 24 is not part of the solution, but everything to the right, or anything greater than 24, is part of the solution. So let's check this. Let's place the number 24 back in the inequality. So 24 is greater than 24. Well, that's a false statement because 24 is not greater than 24. That's why we have an open circle. Let's pick any number to the right of it, like 25. 25 is greater than 24. Well, that's a true statement. So anything to the right of 24 is a true statement. So pause the video, complete the got it problems, and we'll discuss the answer in class tomorrow. Notice I have two got it problems on the slide, got it problem C and got it problem D. So we've just completed the lesson. Go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.